We're going to start off our stats class with looking at categorical and quantitative data and ways to represent that data, and also give you a basic overview of what statistics is. Statistics is really just the science of extracting information from numeric data that we got from an experiment, observational study, or from a sample. Our statistics involves the design of how we're going to collect it, the collecting of it, the analyzing of it, and then once we've analyzed it, what can we say about our results, our inferences? And is this going to be describing only just the sample that we did, or are we able to generalize this to everybody in the population? Now, individuals. Individuals are basically what you're studying. Now, if they're referred to as people, they're called subjects. But it could be like number of freshmen, could be golden retrievers, could be fields of corn, could be number of cells, or the cells you're studying. Now, your variable is basically what it is you are collecting, the information you're collecting from those individuals. Is it their height, their ethnicity, uh, length of the leaf, their blood pressure, their weight? Now, when you're designing your own study or going ahead and reading somebody else's study, you kind of want to ask yourself a few questions. Who? Well, who are we describing in the data? Who are the individuals? Um, you want to say what? How are they defining their variables? What are their units? And why? Why are they doing this experiment or observational study? What questions were they hoping to answer? Do their answers apply to only the people they worked with, or can you generalize it to the whole group? So, based on that, we're going to go through some questions here. Now, when we get to these questions, go ahead and pause the video, read through it, answer it, and then unpause it, and you'll hear the answer that I have. For this one here, since you're looking for individuals, and in this case, what it is we are studying is really each piece of luggage. Once again, pause it here quickly. For this one here, you're wondering, okay, what are we collecting about our individuals? And well, in this case, we're actually going ahead and collecting the information on the number of bags that are over 75 pounds. So as you look through this one here, what is our individual? In this case, it ends up being a person. In this case, it's a person in our large metropolitan area. Now, there are two types of variables. In general, there are quantitative, which is basically something that can be counted or measured. Basically, it ends up being a number. Typically, if it's a number, it's quantitative. If you're describing something with a word, you're going to say it's categorical. But when it's quantitative, we can actually go ahead and find averages and things like that because you're dealing with numbers and you can add your numbers together. And then there's categorical. Categorical would be, it's going to fall into one of several categories where it's not being described with a number. It could be like your blood type of blood type A, B, AB, or O. Could be hair color. We're not able to go ahead and add these together. The only thing we can do with these is tell you the kind of the proportion or percent of how many fall in each category. So once again, if it's quantitative, it's typically going to be represented as a number. If it's categorical, it's typically going to be represented with a word or a short phrase. So let's go ahead and take a look at this data down here. We have our individuals listed on the left. We have our diagnosis, and we have our age of death. In this case, their age of death is going to be quantitative because you're talking about the age, which is a number. Diagnosis is not quantitative because you're not representing them with numbers, you're representing them with words. And people are going to fall into one of several different categories, so therefore it's categorical data here. In this case, when you're looking at monthly rainfall, that's being represented by a number, so it's quantitative. Down below, you're asked to decide if somebody's underweight, normal, obese, or overweight. Since you're not dealing with numbers, you're dealing with words, it's going to be categorical. We want to go ahead and collect our data, but once we have our data, we want to go ahead and examine that data for what it is. After we've examined that data, we want to look for variable or relationships amongst our variables. A lot of times you want to go ahead and give yourself a graph of your data. And then sometimes with your graph, you'll want a numeric summary. But the graph is always nice. A lot of people are very visual, and the graph gives you a different perspective than just looking at a bunch of numbers. Once you are looking at your graph, you want to look at your distribution. What shape does it take on, or what's all showing up in the different categories. Typically, if you're dealing with categorical, you're going to be looking at the percent that fall within each category. Sometimes it'll be the count that fall within each category. So you want to look at the vertical axes to see if you're dealing with count or percent. So here we're looking at categorical data. Categorical data is often represented either as a bar graph like we have here on the left, or as a pie chart like we have here on the right. On a bar graph, your vertical axis is either going to be count or percent. In this case, it's count. Your categories are going to be listed on the bottom. Then how high each bar goes is based on how many people are fitting each category. When you're dealing with a pie chart, each piece of the pie is proportional to how many people are in that category. It's important to note that when you are dealing with a pie chart, you always must be dealing with the whole data. With a bar graph, you don't have to be dealing with all the data. You can just be dealing with most of it. But with a pie chart, you need to be dealing with all of it, unless you adjust your labels. So here, let's take a look at makeup on the first day of school. We have our freshmen, sophomores, juniors, and seniors. We have the percents listed over here. Notice our total percent does not add up to 100%, and that's because of some rounding that occurred in our data. It would add up to 100% if we did not round our data, but we didn't want to have a lot of decimal points going out here to the right, so we rounded it to the nearest tenth, causing us to get slightly more than 100, and that's acceptable. Now that data we're just looking at could be represented as a pie chart. Here, each piece of the pie is proportional to the percent that showed up in each one of those categories. That data could have also been represented as a bar graph. Here, we have our percent instead of a count on our vertical axes, and there, down here, we have our categories. How high each bar goes is based on their percent. The sophomores were 23.3%, so you draw your bar up to a height of 23.3 on your vertical axis. So let's take a look here at the top 10 causes of death in the United States. We have our categories over here on the left. On the right, far right, we have percent of the total deaths. Here we have percent of the top 10. Here you have your counts. Now, not everybody falls within one of these categories, so that's why there's an other category down here. So when we're looking at the first percent column here, This is percent out of just these 10. When you're looking at the far right column, these are the percents out of the total possible ones, including the other category down here. Well, there's different ways you could go ahead and represent this information. Since it's categorical data, you could represent it as a bar graph. Once again, you're going to put your count or percent on the vertical axis, and in this case it's counts. But notice here it says in the thousands, and then on the horizontal axis you have your categories. Now as you look at this one here, we have accidents. Accidents is about the height of 100, but remember that's in thousands. So there'd be about 100,000 accidents in 2001 in which people died in them. You'll notice here heart disease was the most. Now, we don't have to represent our bar graph this way. The top one is the exact same graph we were just looking at. It could be done in any order down here. It could be in alphabetical order, or it could be in reverse alphabetical order, or could be in alphabetical order of the third letter of the alphabet in each one of these. That doesn't make a difference. However, most people will find the top graph where it's listed from largest to least to be the most user-friendly. Is the one down below wrong? No, but it's not as easy to look at and useful. Now, pie charts. We can also represent what we are dealing with pie charts. So each piece of the pie represents the percent that you're dealing with. Now here, once again, it's dealing with the top 10 causes of death. Typically with a pie chart you want to be dealing with percent of the whole, but since we specified of the top 10, we can go ahead and do that. When we were looking back here, we're dealing with percents from this column right here. So we have our key in the right for letting us know what each color over here represents, and then we can see by far these two are the two biggest ones. Now, with your pie charts, here's the same chart we were just looking at. We know our heart disease was 37%. And once again, that was of the top 10. However, your pie chart's going to look a little bit different when you include everybody. Down here, we're looking at all causes of death. In other words, we have this other category. And looking at that list of data we had on the other slide, that would be the far right-hand side where we're looking at all. So here, our heart disease is only 29% when you include the other category, where up here, our heart disease was 37% when you're dealing with only the top 10. So, looking at this one, is this categorical or quantitative? In this case, it's categorical because these are categories. You cannot represent a 3 or 4 times a week as a single number. It's just a category. So how are you going to represent data from that last one? And in this case, it's going to be a bar graph. We've not yet talked about box plots, histograms, and scatter plots.